more than 90% of closed source software had open source software dependencies. We recently saw a study that said not only was that the case, but that 90% of closed source software in this particular survey that they did, which was, thought to be representative, had software dependencies with, potential security issues, which is even more frightening.
Welcome to Shielded, the last line of cyber defense by PQ Shield, the podcast where we are moving the conversation around post-quantum cryptography from the why to the how. I'm Joe Lintzen, your host, and I'm here to guide you through the challenges, innovations, and solutions that will help your organization stay secure in the quantum era. Let's future-proof your defenses together. Today we're joined by Hart Montgomery, Technical Director at Linux Foundation. From his recent findings in critical financial infrastructure to the path toward crypto agility, Hart brings insights from the front lines of post-quantum security. He'll share what organizations need to know about risk assessment, implementation challenges, and strategic approaches to this complex transition. Welcome, Hart. How are you doing today?
I'm doing great. Thank you very much for having me today.
Absolutely. We're excited to have you. So Hart, when we first spoke, I understand you live in Bernal Heights, close to what many consider one of the best breweries on the West Coast. So maybe you can share a little bit of some of your favorite beer.
Oh, that's right. I've always been a big IPA fan, and there's a brewery right nearby called Bear Bottle that has a lot of the best IPAs, I think, in the Bay Area. So my wife probably thought it was too big of a factor for me in moving where we moved, is proximity to this brewery, but I always enjoy it, and I always enjoy a very strong and hoppy IPA.
Yeah. So, and you're in walking distance, I suppose. So
oh yeah,
that makes it even easier.
It's about 2 blocks. It's about a 40-degree hill on those blocks, but that's Bernal Heights for you.
Right. Yeah. That's it has it in the name, I suppose. So I guess, brewing beer is a lot about consistency, right? I mean, that's what the good breweries separates from the rest. They just, crank out very consistent product. And I think in cryptography and cybersecurity, consistency is also key. I found it interesting that you have a PhD in cryptography, and you've focused a lot on scalable, secure blockchain architectures. And before joining Linux Foundation, if I'm not mistaken, you were a blockchain researcher at Fujitsu. So I'd be curious what sort of motivated you, drew you to the field, and if your academic background, and I believe your PhD even is in lattice cryptography, so quite fitting with the post-quantum cryptography discussions that we're having. So I'd be interested how your academic background also influenced your approach to this whole discussion around quantum readiness.
Absolutely. I mean, I think having an academic background in this space is extremely useful. It's not necessarily, for implementing or using cryptography, but sort of understanding all the core mechanics, how things work in detail, is extremely useful. And I've always been someone who likes to see cryptography get applied. Math is beautiful and everything, but, there's a different perspective entirely when you want to work on things that, actually make it to the real world and actually get, real world use. That's why a lot of cryptographers have worked on blockchain in recent times, because it is a way to get cryptography used in practice, oftentimes very, very quickly. I really credit a lot of the big blockchain communities, like the Ethereum community, for instance, for really being progressive with adopting new cryptography and cryptographic techniques. So naturally, a lot of cryptographers have been drawn to that space, particularly the ones that care about, seeing cryptography work in the real world. Now we're seeing that in the post-quantum space too, which is really exciting.
Well, I mean, speaking of real world examples and, the things that you shared with me sort of preparing for this podcast. You did mention that you recently were involved in a security audit at a large unnamed financial organization, and I think you used the word scary to describe the results. So I'm sure our listeners would be curious to hear what the most concerning findings were within that report.
Oh man, and I've seen another report recently that there's a big open source study. So we used to always cite at the Linux Foundation that more than 90% of closed source software had open source software dependencies. We recently saw a study that said not only was that the case, but that 90% of closed source software in this particular survey that they did, which was, thought to be representative, had software dependencies with, potential security issues, which is even more frightening. And I've seen a number of big orgs, I wouldn't say I'm involved in the security audit directly, but I've, talked to people about results, and, it is frightening. You see things like MD5 certificates, just, really, really old, cryptographic code. And it's sort of like, why does this stuff exist? Somebody yesterday was telling me about how they found a single DES in somebody's code base like 10 years ago, which is like, okay, that's pretty bad. So, a lot of this is just organizations not necessarily having the cryptographic expertise or the security expertise to properly, put in place policies, and really, enforce updates. If you have an org where a dev can just kind of go pick out their own cryptographic algorithm and put it in and use it, then you're going to have problems.
Mm-hmm. So it sounds like the migration towards, quantum safe cryptography really isn't from, a baseline of what is considered best practice today. It's in some cases, migrating from something that was considered best practice 10, 15 years ago. And I think, financial organizations are probably the best example because they, even using still triple DES in some of the, arguably, payment transactions are short-lived, right? So, there's less of a challenge there, but triple DES has been, considered obsolete for 15 years now, something like that.
Or in some cases, not using best practices altogether, or in some cases, just not being consistent. This you really hit on a good point here, and this gets into cryptographic agility, which everybody talks about these days. If you have a crypto microservice or library, and everybody in your company uses it, then it's much easier to potentially do a migration, right? I'd say crypto forward organizations have this kind of thing, like a lot of the big tech companies like Google, AWS, where, migration is really just somebody on the security team or a committee of people on the security team really, changing a parameter to an algorithm, right? Obviously there's a lot of consideration that has to go into that, because there could be, breaks and unintended consequences. Maybe some protocol is reliant on a signature plus some other stuff fitting in a packet, right? And then if that doesn't happen, then, something unexpected happens. But that kind of thing is like much more straightforward than people, that have sort of hard-coded ECDSA into their code base everywhere, or, specific hash functions with, very specific, input sizes. So that kind of thing is much harder to migrate.
Yeah. Well, so I think you used the term before, right? Policy-driven approach to this, of course, would be ideal. And then if you had something centralized, like a crypto as a service solution almost, that then, doesn't allow the developer necessarily, like you said, to choose, their own hashing algorithms or signing algorithms. They just have to follow policy, and that gets, and that gets put into place by, role-based controls. And then I suppose, how would we bridge over to, quantum readiness within such a centralized crypto as a service solution? How would what could a migration look like if there was such a thing as a centralized control?
Well, it's much easier if you have some kind of crypto microservice, right? Or general architecture. So if you look at sort of recent publications, I would say not formal publications, but blog posts or other things by, Google and Amazon, I'll use them as an example. IBM also has some stuff on this. They really segment cryptography applications into a number of different types. Basically things where PQC migration is very inexpensive in the grand scheme of things, or things where it's more expensive, right? So, for instance, for signatures, right? The biggest drawback with the post-quantum migration for signatures is the signature sizes are generally, they're always larger, right? Pretty much. And the keys can be larger. So, in some cases, this doesn't matter, right? And, it's a similar thing for public key encryption or key exchange. I mean, I'm sure you know this. Most people who work with this a little bit know this. But for instance, if you're, running TLS or SSL or something, right? The initial key exchange at the very beginning is a very, very, small part of most sort of traffic flows, right? So if you have a little bit of extra overhead, if you have a few, 10 kilobytes even, say, of overhead, and your whole exchange is in the megabytes, well, it kind of just doesn't matter, right? So, we've seen a lot of adoption for that, for things like messaging, where it's also, relatively inexpensive, where we've seen Signal and Apple, already sort of push through these migrations. So, for things like that, it's easy. And for some other things, it's like quite expensive, right? Like for certificates, if you're dramatically increasing signature sizes, then you're just dramatically increasing certificate size. So, so stuff like that is a little bit more complicated, but, if you have these like nice microservices, you can just switch, with the single parameter, you can just switch these things, one by one, make sure everything's okay, and do sort of a very easy migration. Somebody yesterday, the comment was all migrations are hard. Some migrations are easier than others. So
right.
Easy flow migration.
Yeah. Well, I think, you laying out the less resource intense, things like TLS handshakes. I think that's also the reason why we're seeing the first migration steps happening within exactly those use cases, right? Because that seems to be, as much as I don't like the term, but that seems to be the low hanging fruit for PQC migration, right? To go, okay, let's exercise that through and see what results we can get, right? And I think it's interesting that you mentioned AWS and Google and IBM as sort of examples of, well, they've solved some of these issues for you, right? So to me, that is the digital supply chain for the large organizations, right? That they're using those services. And I think it's always interesting to look at, well, what are the capabilities that, like, if I'm a large organization and I'm tasked with that migration, like, what are the capabilities? What are the questions I should be asking my vendors, my providers, as I evaluate those solutions and see if they might be a fit for, my specific use case?
Yeah, I mean, that's a great question. I think those companies are sort of, even more unique because they have, bunches of very good cryptography PhDs, which is, not typical even in a technology space, or especially like a financial firm space. And mostly, like particularly Google and Amazon, are not necessarily, they're focused on their own services. Mm-hmm. So, and, I think they do a very good job of that. So yeah, they've made all these, they've made all these sort of migration priorities, and it's like, well, we need to secure this, and it's really interesting to sort of see their decision making, because they put a lot of thought into this stuff.
Yeah. So listening to your to your explanations, I think we can say, well, cryptographic agility is key. Centralized crypto as a service type offerings can help with rotating keys and making the transition much more seamless and less painful. In general, I think the whole migration to me feels like we have to walk up a steep hill in Bernal Heights to eventually get to that state that we want to be in with, protecting our environments from the quantum threat. I think, it's probably historically speaking, and also for this migration, it's fair to say that regulation has been, much of a driver for this. And then I think, PQC migration is no different. Do you see compliance as a catalyst for action, or, are the global standards moving quickly enough to support those organizations that are making the early moves? I'd be curious to hear your take on that aspect of the whole migration.
Yeah, absolutely. I mean, regulations are driving a lot of this. There are some very sort of security forward and security conscious companies, certainly, again, the big tech companies that employ legions of security and cryptography PhDs tend to be very aware of things and very aware of the risks. That's not the norm in, the broader industry. And we do see a lot of people who sort of, it's just like, well, I just want to make sure I'm okay with the government regulations, right? The U.S. government has been very aggressive about requiring, post-quantum protocols in the future. So yes, that is absolutely driving adoption, and anyone that wants to, contract with the government or work on government stuff is definitely paying attention to this. So I think that's a really huge driver.
Good. No, I agree. And I mean, besides the U.S. federal government, I think just today or yesterday, UK released their version of the guidelines. They too have 2035, kind of that 10-year window that they push forward. I believe Australia is even a little bit more aggressive with those timelines. Now, the other thing that I was reminded of as we were talking about open source being part of a closed source software in 90% of the cases. Of course, one way to approach it is the software bill of materials, right? To sort of have that list of dependencies and be clear about it. And closely related to that, we have the CBOM, cryptography bill of materials, that addresses which algorithms are being used and such. And I believe you mentioned that maybe IBM did a large open source project together with the Linux Foundation around CBOM. So that certainly helps to address the quantum readiness as well. Maybe you can speak to that a little bit.
Yeah, that's really about helping organizations, find and locate, where they potentially have post-quantum cryptography. And, SBOMs are, in the bigger picture, SBOMs are, completely essential at this point, right? It's hard to trust a large software project that hasn't gone through the work of putting together an SBOM, particularly if there are a lot of dependencies. We sort of refer to it as the open source hamburger, where modern software development is basically done in the following way. You pick a framework, that's one of your buns. It's usually an open source framework. You do a little bit of custom code, which is sort of the meat. And then the other bun is all the open source libraries you pull in and use to solve problems. And it turns out the custom code that most people write for these, modern software projects is like quite small, right? It's like maybe 20% of the code in an overall project. But of course, when you do things like that, you have to have SBOMs. particularly well, so people know what they're getting, and also, so if there's a security vulnerability report on something, they can, and you can easily update the required component. We see this all the time where I'll go through and just take a deep dive on a big project, and it's like, well, you're pulling in this code from this GitHub repo. There's one guy maintaining it. He hasn't touched the code in 4 years. Like, are you sure you want to do this? So it's these kinds of questions. C-bombs are also, super important for this post-quantum transition. And I think in general, you want to make sure that people are using up-to-date cryptography. You want to make sure that people are consistent and having this information available to you without having to do your own sort of deep dive into the code is extremely, useful.
Well, and that kind of goes back to your earlier comment on the security reviews that you've seen within the financial organizations, right? I'm pretty sure that was eye-opening for many, probably even up to the CISO level. They went like, wait, we're still using MD5? I had no idea. Great that we're finding all these issues now. And that's certainly going to help to do the risk assessment and to say, well, where's our most critical data? Where do we start with this? Right?
Yeah, absolutely. And it goes back to the microservices and crypto agility point, right? Ideally, you'd like your developers to understand cryptography in sort of a black box way. So what I mean by that, right, is, they understand what a digital signature is and what it does, right? It gives you authenticity, right? They understand what, key exchange or public key encryption does, right? But it's not reasonable to expect, everyday developers to understand the math behind all of these systems or to be able to decide which one to choose, or anything like that, right? It's like, well, should I use ECDSA or Schnorr, right? Well, if you're a developer, they're probably indistinguishable to you, right? So it's not fair to ask devs to make these decisions. But, what you can do is you can say, okay, call this function for your signatures. It will, we'll always make sure we have, a high security, efficient implementation in there. And, you can just do that in general. And there will be some exceptions, but, to get an exception, you kind of need to know what you're doing and have a good justification for it.
Yeah. And ideally have, 2 or more people take a look over it and ideally with some deeper knowledge of, like you said, a developer might be, really good at developing code, but they might not necessarily be really versed in the latest and greatest cryptographic algorithm and how to use it. And also which implementation, quite frankly, which implementation to use, right? Because typically it's not necessarily the algorithm itself that breaks. It's a poor implementation that, will be under attack and will eventually allow the bad guys to come in.
Absolutely.
Yeah. So a lot of organizations that we're talking to, they have a challenge of identifying that initial use case and sort of getting that C-level buy-in. Is there any recommendations you can give to say, what's a compelling business case to bring to the boardroom and get accepted to get started with, get some quick wins?
Absolutely. So the example I like to bring up is the classic harvest now, decrypt later problem. So what this means is, obviously you know this, but basically, however you're using data, it's probably being transmitted across the internet today. And people are recording this data, right? Whether it's nation state adversaries or competitors or whoever, right? People might write your data down. Now, the problem is if I write your data down today and a quantum computer comes out 5 years from now and you used, I don't know, an ECD, you use some kind of elliptic curve based key exchange to set up your secure connection. Well, I can go back and decrypt all that data now, right? And if you needed that data to be secure for longer than 5 years, you have a problem, right? So this becomes a game of sort of how long does my data need to be secure versus when do I think a quantum computer will be ready? The latter is a difficult problem. Like, people ask me this all the time, but I am not a physicist, so I have no idea. I'm just, I just say, you got to ask the physicists, right? And that's a speculation game, right? Every year there are a couple of organizations that sort of poll all the physicists and say, like, in every sort of interval of 5 years, what's the % chance you think a quantum computer will be, powerful enough to crack RSA 2048 or something like that, right? I think those are really interesting and useful. Again, we don't know for sure, but that's sort of the best we have. But the other side is much easier to sort of guess or estimate. Like, organizations generally should know how long their data needs to be secure. That's unique to many organizations. But this is the general calculation. The wild card is also trusted hardware. If you need cryptographic supported hardware, then this just throws a whole nother sort of epoch on the timeline, right? Because you need to decide a protocol, fix the hardware, manufacture the hardware, have it out, all sort of in time before, you need to add that to the length that your data needs to be secure. So that's probably the most worrisome for me is reliance on trusted hardware. And can we have that ready in time?
Right. Well, and that really ties back into the critical infrastructure, right? I mean, we used financial as an example for critical infrastructure, but of course there's, things like power supply, water supply. There's like millions of devices deployed out in the field. That is a huge challenge to upgrade all of them. And no one's going to go in and rip and replace, because I mean, that's just cost prohibitive. But coming up with smart ways of migrating those long-lived devices out in the field, even more important to get started with the planning now. If you look at those timelines of 5 to 10 years, so I think and then it becomes about a game of balancing like your immediate security needs and sort of your long-term planning. Do you have an example for sort of that balancing act, maybe?
That's a tough one. And I am, very, very worried about sort of the IoT and as you put it, the small cryptographic hardware pieces, right? So like your power meter, right? You might have a smart meter. That's got to get updated and replaced, right? All the little things like that are exceptionally problematic. The power company is definitely not going to have cryptographers working for it. This is probably on what I'm most worried about. Are these, non-tech associated or tech adjacent hardware devices that are updated very, very infrequently. And some of them are extremely critical. So, I'm not sure there is a good solution for this. Some of them, there's no choice but to rip and replace, right? It's problematic.
Tying the conversation back into sort of the Linux Foundation activities, and I know and appreciate you joining us in such a busy week with the member summit taking place. You did mention some interesting takeaways from the keynote. Maybe you want to share that as well. I think it ties nicely into authentication and the discussion about open source project.
Absolutely. So one of the big things that has been on the Linux Foundation's mind recently are software supply chain attacks. Obviously, we talked about SBOMs, in particular this like XC utils attack that happened not too long ago, where a person operating or people operating under the identity Jiatan found a sort of critical project in the open source supply chain that was also under-maintained, volunteered to help maintain it, and then installed malware essentially into this project to try to, compromise a huge amount of our digital infrastructure. So this is extremely worrisome. And it's like, how do we stop this kind of thing? What can we do? And one of the proposals was, well, this wouldn't have happened if we only sort of allowed trustworthy people or people we could identify as trustworthy with some chance to contribute or maintain these projects, right? Especially maintain the projects. So the idea was that, well, if we think about what the kernel does, right? The Linux kernel requires people, if you want to be a maintainer, you have to go meet other kernel maintainers and show them your government ID and documentation. This is an extremely tedious process for them. Sometimes prospective maintainers will have to go drive hours to go meet people in different cities. So not the greatest for them. And the idea is that, with advancements in digital identity and digital credentials, we can sort of do all this digitally, and keep it privacy preserving using zero knowledge proofs. And, of course, this won't totally, stop the problem. A super dedicated person could obviously, spend years and years and years building up a reputation before, doing something. And we jokingly accused Greg Crow-Hartman, who's the number 2 guy on the Linux kernel, of being you say, well, what if you're a long-term spy and you've built up this position in the kernel to launch an attack? But, we can hopefully mitigate a lot of these problems where, just sort of low reputation, high risk people are given, access to some of the most important code running, a huge amount of our digital systems today.
Well, that goes back to the beginning when we were talking about consistency, right? It's if you're the protector, you have to get it right each and every time. If you're the bad guy, you only have to get it right once, right?
Yeah,
that's all it takes. Yeah. Well, Hart, look, this has been a fascinating conversation. Really appreciate you taking the time out of your busy schedule. Before we close up, do you have any sort of best practices for organizations just getting started on this? Like, what are the top 3 things to get started with today to sort of be ready?
Yeah, that's a great question. So I would say, number 1, even if you don't have a plan for a plan. You can call it concepts of a plan if you like. Just think about, particularly for Harvest Now, Decrypt Later, how long your data needs to be secure, and when you think quantum computers might be viable for breaking cryptography. The second one I would say is start re-engineering your crypto code now to be crypto agile. People always ask, what should I do now? And I always tell them, build in crypto agility to your systems. It's best security practice anyway, so you should be doing it. And, you don't even have to say that, oh, look, this is for a post-quantum migration. You can just say, this is so we're secure today and we're following best practice today. And third, I would say is think about any sort of unforeseen effects of using cryptography in sort of a non-black box way. I alluded to the example earlier of some protocols were designed around a signature fitting into a single packet. And obviously having a much larger signature would break that assumption, right? Or it could. So just think about also those things where you're relying on cryptography having, some particular property, and make sure that doesn't change and you don't need to re-architect your system around that.
Fantastic. Thank you. That's very valuable. And then lastly, before parting ways, do you want to share with our listeners where they can follow your latest work, latest and greatest that's happening for you at the Linux Foundation?
Sure. Yeah. We have a bunch of projects that work on and touch cryptography at the Linux Foundation. The Post-Quantum Cryptography Alliance is the one directly related to post-quantum cryptography, or we have things like the OQS, the Open Quantum Safe project, which many people are familiar with. We also have, Linux Foundation Decentralized Trust, which has a number of cryptographic protocols in it. A lot of stuff around, MPC, threshold crypto. The Open Wallet Foundation is another project that works with things like anonymous credentials and stuff like that. So check those out. We have a lot of code, and we're the Linux Foundation. We're open for everyone to contribute.
Fantastic. Thank you so much, Hart, for sharing your insights, and this has been a great conversation.
Thank you very much.
The quantum era is already here. With the right tools, the right knowledge, and the right mindset, together we can face it head on. To find out more about PQ Shield and how our cutting-edge solutions can help you secure your data against the quantum threat, visit pqshield.com. Make sure to search for Shielded, the last line of cyber defense, in Apple Podcasts, Spotify, or anywhere else you get your podcasts. Don't forget to click subscribe so you never miss an episode. On behalf of the team here at PQ Shield, thanks for listening.